Okay, let's look at the homework 2.3, 2.4, problem number 15. Right. So we're going to use a graphing calculator or GeoGebra. I'm going to use GeoGebra to for given epsilon values 0.2 and 0.1. We want to find the corresponding delta value. Right. So let's do that. So I'm going to bring up GeoGebra. Right. So the function was. Right, so I'm going to just call it f of x, and the colon equals to define the function, and the x cubed minus 5x plus 4, right? Then hit enter. Right, it draws a picture, and x is approaching 3, so I'm going to put the x equals 3 to draw a vertical line there. And also limit is 16, so y equals 16, right? So we have that, right? It's we cannot see it, so I'm gonna just bring this guy down a bit. All right, so here, so this is 16, and that's 3 right there. So I'm gonna just put it right in the middle, all right? Then we want let's see, epsilon value to be. So I'm gonna just give the epsilon value to be 0.2 for the first one, right? So hit enter. So now program knows that the epsilon is 0.2. So we do y equals 16 is the limit value, so we have to minus epsilon. So epsilon here, epsilon. All right, then hit enter. Right, so that's the lower bound, and the upper bound would be y equals 16 plus epsilon. So go here and click on that, right? Then hit enter, right? So this is the kind of acceptance region, right? Then we want to find find out how small the delta needs to be so that the graph is in between these two lines, right? So in order to do that, I'm gonna just zoom in a little bit. It's kind of hard to see here, so I'm gonna just use the zoom in tool to zoom in. Maybe zoom in a little bit more. I don't know, maybe more, and maybe more, and more. All right. It's still kind of hard to see. I'm gonna just do it a little. Okay, so this is 16 plus epsilon here, and this is 16 minus epsilon. So delta needs to be quite small to get it in between those two, right? So in order to find that, let's see, we have to find this point and also find that point, right? So I'm gonna just use the intersection tool. So that's intersect two objects. So here you do that. And this is a lower bound here and the graph, right? That's the intersection. And here's upper bound and the graph. That's another intersection, right? So you can see that, let's see, delta value needs to be either 0.0091 or so, right? And here, what's the difference between 3 and this value? So I'm just gonna go ahead and do that. 3 minus 2.9908 75. I think that's enough, so I'm going to do that. All right, so that value is 0.009125, and here the distance between here and there is actually 0.009057, so this is smaller, so we have to take that as the delta value, right? So we're gonna have let's see, 0.0091, right? So let's type that in. Right, so it's around to answers to 4 decimal places, so it's going to be 0.0091. right? So we got that. All right, then we have to do the same thing with epsilon being equal to 0.1. All right, so let's do that. Alright, so I'm gonna just change this value. So I'm just gonna right click on that and then object properties. Then I just change that value to 0.1. Right, then you can see that it narrows, and the intersection actually changes accordingly. So you can see that it's going to be 0.0045, right? So let's look at this one. Let's say 3 minus 2.9954 6. I think that's enough, right? So that value is 0.0045. So this is a 454. This is a 0.0045. It's the same thing. So it's a 0.0045 is the corresponding delta value. So let's type that in. Right, 0.0045. Right. So we have 4 decimal places. All right. So let's just check to see if it's correct. All right, it came back and looks like we got these values correctly. All right, that's it. I hope that this was clear.